Okay, the lesson is called Multiplying Rational Numbers, and you're going to learn to multiply fractions, decimals, and mixed numbers. There's a lot to take. Okay, we're going to multiply here and write our answer in simplest form. I like to have, we have this number multiplied by this number. I like to have them both be in fraction form. So I'm going to write this as -8 over 1. Putting something over 1 does not change its value, times 6 over 7. And then we simply do numerator times numerator and denominator times denominator. -8 times 6 is -48, and 1 times 7 is 7, giving us -48/7. Now this is an improper fraction right here, so we need to simplify that. Equals, let's go ahead and put the negative so we don't forget it. 7 goes into 48 6 times, so our whole number is going to be 6. 6 times 7 is 42. 42, when we had 48, leaves us with 6, and we keep our denominator. So our answer is -6 and 6/7. Okay, same situation here pretty much. I'm going to put 2 over 1 times, oh, we've got this 5 1/3. In order to multiply fractions, we need to have an improper fraction rather than a mixed number. You do 5 times 3 is 15, plus the 1 is 16, over, keep your denominator, is 3. Then we multiply numerator times numerator and denominator times denominator. 2 times 16 is going to give us 32. 1 times 3 is going to give us 3. Again, we have a mixed number. 3 goes into 32 10 times, with 2 left over, and keep our denominator of 3. So our answer is 10 2/3. This time we have -3. I like to put that over 1 times 5 over 8. Gives us -15 over 8, which is an improper fraction. 8 goes into, let's keep our negative first of all. 8 goes into 15 one time, with 7 left over. 7/8 cannot be simplified, so we're done. Okay, let's take our 4 and put it over a 1. And we need to change our 9 2/5 to an improper fraction. 9 times 5 is 45, plus 2 is 47, over 5. Then we'll have to do 4 times 47. That equals 188. Over 1 times 5 is 5. Then we're going to have to figure out how many 5s are in 188. You may need to come off to the side here and do a long division problem. How many 5s in 188? It goes in 37 times, and then we have 3 left over, so that's our numerator, and our denominator stays the same. So we've got 37 3/5. I'd like to show you a little representation of what multiplication of fractions means. We're doing the problem 3/5 times 2/3 right here, and this is a model of 3/5, and this is a model of 2/3. When we multiply them, do you see how we took this picture and kind of put it over here, and took this picture and also put it over there? And then the answer is this part where they overlap, which is 6/15. That part right there, 6/15. And it equals 2/5. So the what the multiplication actually means is this right here. And notice when we're multiplying fractions that are less than 1, our final answer is less than either one of them. We're going to work on some canceling here. There's nothing wrong with the way this problem's written, but I just kind of like to write it like this. 1/8 times 6/7. Okay, now, if you just went ahead and did numerator times numerator, denominator times denominator, you would get 6 over 56, and then you would have to divide that by, let's say, 2 over 2, which would give you 3 over, what is that, 28. 3 over 28. Okay, now I want to show you a different way to do that problem, though. 1/8 times 6/7. You can kind of do your reducing or simplifying up front. What you have to recognize is that 6 on the top and 8 on the bottom share a common factor of 2. Take 6 and divide it by 2, call it 3. Take 8 and divide it by 2 and call it 4. And now do numerator times numerator is 3. Denominator times denominator is 28. And you have your answer. Now, the reason that was helpful is it even took me a second to do 56 divided by 2 and to even look at this and determine what the greatest common factor is. You're dealing with bigger numbers if you do your simplifying at the end. So I recommend canceling all that you can. All right, here's a new problem. Again, I like to write it like this. You've got a negative times a positive. It's very easy to forget that negative, so I like to put it in an answer box down here at the bottom as soon as I notice it so I don't forget about it. The simplest kind of simplifying is when you have the exact same number, 1 on the top and 1 on the bottom. So 2 and 2 both have a common factor of 2. 2 divided by 2 is 1. 2 divided by 2 is 1. Now, just because we've canceled once doesn't mean we can't cancel more. 3 and 9 also have a common factor of 3. 3 divided by 3 is 1. 9 divided by 3 is 3. Now we do top times top is 3. Over bottom times bottom is 1. Keep our negative. 3 over 1 simplified is just 3. So our answer is negative 3. Hopefully you're noticing that this is an mixed number, and in order to multiply fractions, you need to make that an improper fraction. 4 times 7 is 28, plus the 3 is 31 over 7 times 1/2. There is nothing here to cancel. There are no factors of 2 up here, no factors of 7 up there. So you just do 31 times 1 is 31. 7 times 2 is 14. That's improper. 14 goes into 31 2 times. That's 28, leaving us with 3 left over, 3/14. And 3/14 is already simplified. So our answer is 2 and 3/14. So our problem is 3/5 times 5/8. We're looking to cancel. We've got a 5 on the top and a 5 on the bottom. That's the simplest kind of canceling. Those both go away and become 1s. 8 and 3 do not share a common factor, so there's nothing else to cancel. 3 times 1 is 3, and 1 times 8 is 8, and 3/8 is already in simplest form. Negative 7/8 times 4/7. Again, I notice I have a negative times a positive, so I know my answer in the end is going to be negative, and I don't want to forget about that. We have a 7 on the top and a 7 on the bottom, so those go away and become 1s. The 4 and the 8 can also be canceled. They share a common factor of 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Then we do 1 times 1 is 1. over 2 times 1 is 2, and our answer is negative 1/2. Let's recognize this mixed number needs to be changed to an improper fraction. 2 times 5 is 10, plus 3 is 13 over 5 times 7 over 9. We look for opportunities to cancel, but there are no common factors top and bottom, so you're just going to have to go ahead and multiply that out. 13 times 7 is going to give you 91. 5 times 9 is going to give you 45. And that's an improper fraction. So 45 goes into 91 2 times. 2 times 45 is 90, so that leaves us with 1/45 left. All right, we're changing now to multiplying with decimals. I know some of you like to use lattice, and that's fine if you want to use lattice. Let's take this first problem A, and let's just copy it into a space where we can work it. 0.51. Notice we've got a positive times a negative, so I know my answer is going to be negative in the end, so I'm just going to ignore the negative until I get there. Times 2. If you're doing traditional, I like to put the number with more non-zero digits on the top. It makes my work easier. Then I do 2 times 1 is 2, 2 times 5 is 10. And then I look at the problem and I count up how many digits are after the decimal point in the problem. This one is after the decimal point, and this one is after the decimal point, so that makes 2. So I'm going to put my decimal point right here. Sorry, that's 1.02. So I have exactly 2 places after the decimal point in the answer and 2 places after the decimal point in the question. And I don't want to forget about my negative, 1.02. Okay, we've got another problem to work here. Notice that this one has only 1 non-zero digit, and this one's got 3 of them. So I'm going to put this one on top. We have negative times negative, so I know my answer is going to be positive. So I'm going to take care of that and then not worry about the signs. That says positive. Notice also that my decimal points do not need to be lined up for multiplication. 4 times 5 is 20, put the 0, carry the 2. 4 times 7 is 28, plus that 2 is 30, put the 0, carry the 3. 4 times 3 is 12, plus 3 is 15. Now I look at the problem and count the digits after the decimal point. This one, and this one. So I have 3 digits after the decimal point in my problem, and I need 3 digits after the decimal point in my answer. Put that decimal point in, and then you know that zeros at the end after the decimal point don't mean anything, so my answer is going to be positive 1.5. In this problem, there are 2 digits that are not zeros in each of those numbers, so it really doesn't matter which one I put on top. So I'm going to put 3.1 times 0.28. And again, it's not necessary to line up the decimal points. And we don't have any negatives, so our answer is going to be positive. We do 8 times 1 is 8. 8 times 3 is 24. Then we put a 0 here. 2 times 1 is 2, and 2 times 3 is 6. Then we add and count up our places after the decimal point in the problem. 1, 2, 3. So we need all 3 of those after the decimal point in the answer. And we'll put a 0 here just for good form. Okay, in problem B, let's notice that we have 1 non-zero digit and 3 non-zero digits. So I'm going to put the one with 3 on top, 2.53 times 0.4. I'm going to go ahead and deal with these negatives right now. Negative times negative equals positive, so I know my answer in the end is going to be positive. 4 times 3 is 12, put 2, carry the 1. 4 times 5 is 20, plus the 1 is 21. Put the 1, carry the 2. 4 times 2 is 8, plus 2 is 10. We have 1, 2, 3 places after the decimal point in the problem, 3 in the answer. So our answer is positive 1.012. Okay, we're back to fractions. Our directions say to evaluate this expression for the value of x, and they told us that x equals 5. So we're going to write the expression negative 3 1/8, and then in place of the x, we're going to put 5. In order to multiply that, notice that we have a fraction, so we need to take this mixed number and change it to an improper. 3 times 8 is 24, plus 1 is 25 over 8 times, and we can put the 5 over a 1. Let's notice that we have negative times positive, giving us a negative answer, so let's take care of that. There is nothing to cancel here. 25 over 8 and 5 over 1, you can't cancel top and top. It has to be top and bottom, so there's nothing to cancel. So this gives us 125 when we do top times top over 8. Now we need to know how many 8s are in 125. We probably don't know that, so we'll have to work a long division problem. 8 goes into 45 5 times, and we get 5 left over, so that's 15 and 5/8. That goes there, and that goes there. Negative 15 and 5/8. 5/8 cannot be further simplified, so that's our answer. Okay, we have the same expression here, but we're plugging in a different value for x. Negative 3 1/8 times 2/7. Let's put our negative down here in our answer. And 3 1/8 again comes out to 25 over 8 times 2 over 7. We do have something we can cancel this time. 2 and 8 share a common factor of 2. 2 divided by 2 is 1. 8 divided by 2 is 4. Now we go ahead and multiply, and we get 25 over 28, which cannot be simplified. We remember that our answer is supposed to be negative, so it's negative 25 over 28. This time they gave us a different expression. So we've got negative 5 3/5 times y is 6/7. Let's take care of our negative. Negative times positive is going to be negative. And we need to change this mixed number into an improper. 5 times 5 is 25, plus 3 is 28 over 5, which is very convenient because we've got a 7 on the bottom here. 7 and 28 share a common factor of 7. 7 divided by 7 is 1. 28 divided by 7 is 4. We don't have anything else that we can cancel, so we do 4 times 6 is 24 over 5 times 1 is 5. 5 goes into 24 4 times with 4 left over. Keep the denominator. Nothing can be simplified, so we remember that our answer is going to be negative. Okay, they gave us the same expression with a different value for our variable. Okay, let's take care of that. Negative times positive is negative. This as an improper again is 28 over 5, and we'll put our 3 over a 1. This time we don't have anything that we can cancel, so we're going to have to actually do the 28 times 3. That's going to give us 84 over 5. We got to figure out how many 5s, since it's improper. How many 5s are in 84? So we got 16 and 4/5. 4 goes there, 5 goes there. 16 and 4/5, which cannot be simplified, and we remember to make that negative because we had negative times positive. Okay, here's a little quiz for you to do. Go ahead and pause and come back for the answers.